Good morning, everyone. I hope you had a great weekend. Now it's Happy Monday, and time to get on with some macroeconomics. The first week, we discussed different economic aggregates that we're going to study during the semester. And then last week, we started to... Let's try this. We started to do a bit of theory, which is to try and understand why it is that the aggregates do what they do. We started with this broad idea that we're going to try and use the theory of aggregate supply and aggregate demand to try and understand how economic aggregates behave. And so today, even though we haven't done very much theory, we're going to start off by trying to attack one of the big themes of this course, which is the question of why does economic growth exist? Okay, so we've only just started doing theory, but we already have enough that we're going to be able to say something about what, at least to me, is perhaps the most important economic phenomenon that we see, economic growth. Now, the way we're going to approach the study of economic growth is that we're going to do a little bit of economic history. And what I mean by that is we're going to start by trying to see how, so to speak, early economists thought of economic growth. And early doesn't mean that long ago, like 120 years or something. But we're going to refer to that approach, which will be, as I said, something that we can analyze, even though we've only just started talking about economic theory, that we're going to call Neoclassical Growth. Okay, so we're going to start by looking at this, which is the way economists confronted with information on economic growth, how they started thinking about why it might be the case. We're going to see that thinking about economic growth the way, so to speak, early economists did is going to be very useful for understanding certain things, but is also going to have certain limitations. And so a little later, another group of economists came along and came up with what is referred to as New Growth Theory. It's not new anymore, but for some reason the name stuck. Right, this is associated with people like Schumpeter, who came up with this stuff 100 years ago, but for some reason it's still called New Growth Theory. That'll help us get a little further. We'll see that it also has some limitations. And finally, we're going to try and complete our picture of how economic growth works around the world by looking at, I guess it's not really a separate theory. It's a sort of a separate set of issues. I'm just going to refer to it broadly as institutions. So these are different names for different theories, but what we're going to see is that it's not just that they have different names, it's that they have a different emphasis. What we're going to see right now is that neoclassical growth is going to emphasize, is going to rather start from thinking about the role that capital has in economic growth. This one is going to focus on how it is that technical progress might emerge and affect economic growth. And this one is going to do the following. Remember that when we talked about technology, it involved a variety of different things. On the one hand, there were things like scientific knowledge and so on, which would kind of fit in here, right? But on the other hand, there are also things like the way the economy is regulated, the way the legal system functions, or the legal system fails to function. That's the kind of thing that we'll be looking at towards the end. Okay? So that's our plan. We might get through it this week. If not, it might spill over a little into next week. Either way is good. All right. Any questions, comments, thoughts before we jump in? All right, so let's start with this one. To start thinking about economic growth, actually I guess I should say, this name neoclassical is used in all sorts of different contexts to mean different things. In this context, it basically just means this is a bunch of microeconomists trying to figure out how growth works. Because I know the term has some political connotations and so on, they don't really apply here. Okay? It's just a name. So let's think about neoclassical growth, which is basically it's basically a bunch of microeconomists who have taken Econ 1 and are trying to use it to try and understand the macroeconomy, where they notice that growth is a thing. And you'll remember from last week that one of the things that we did, I guess this is a bit of recap, is that we came up with a simple image of how it is that production occurs. So you should remember this idea of the production function. We'll write it out. And it comes down to the inputs go into some process that we called technology, which combines the inputs, and the inputs are some combination of labor, capital, and I guess maybe things you dig out of the ground. And out comes the output. I'm going to write real GDP because that's to remind us that we're in a macro context here. And you'll remember that last week we discussed the idea that if there's economic growth, at least one of two things has to be true, right? If there's economic growth, in other words, you're not just getting more real GDP, but you're getting more real GDP per person, at least one of two things must be true. Either, for some reason, the amount of inputs that you're using is going up over time, or the technology is improving over time. So we're going to use a little bit of micro to try and figure out which one of these seems the case, seems more likely to be responsible. Now, one of the concepts that you probably came across in micro early on was the concept that actually shows up all over the place in micro theory of diminishing marginal returns. You remember this, right? So what's the idea? The idea is that the more you have of a certain input, the less additional oomph you get out of it. So for example, if I'm sitting in my office and I have one computer, I can produce a certain amount of economics lectures and economics research projects and whatever it is that I do in my office. If you give me a second computer, it might make me a bit more productive, but it's not going to double my output. It's going to increase it by less than whatever I could get from the original one. If you have a third one, it probably isn't going to add much productivity to me at all because, I only have two hands. And I can only use one computer at once. I only have one brain. So that's the idea of diminishing marginal returns. Now, take that idea. Actually, it's decreasing returns to scale, diminishing marginal returns, same idea. I'm going to write both just in case. So, you may remember, whoops, that's a typo, a righto. You may remember this concept from when you were in micro. Actually, that was right. And it showed up everywhere, all over the place. It showed up when you were talking about production. It showed up when you were talking about consumption as well, because the more you eat of a particular good, the less additional utility you got out of it, of each added unit. Suppose we take this key idea from micro and apply it here. What is it going to tell us? Well, if there are diminishing returns to inputs, what does that tell us about the role of inputs in economic growth? It means that sustained increases in inputs cannot be the deep cause of long-run economic growth. How come? Well, each additional input of, let's just say, capital that you add is just going to be a little less productive than the last one. If you keep increasing, let's say, capital over time, what you're doing is you're lowering the additional benefit of each one. Now, making capital isn't costless, right? There are actually two costs of capital. One is the fact that you may remember when I wrote here how we measure capital, there was this idea of depreciation, right? Capital breaks down. So you can't just increase capital willy-nilly. Part of any added capital is just replacement. So if you want to add capital, you have to add it beyond how much you're trying to replace. And second, if you're using resources to make capital, it means you're not using those resources to make consumption goods. So there's an opportunity cost to increasing your capital stock. And as we just discussed, if there are diminishing returns to scale, that means each time you increase the capital stock, its added value is getting smaller and smaller. Its added value in terms of how much it produces. So the more you invest, the more you sleep. In order to invest in new capital, you have to sacrifice something, but the more you invest, the less useful it gets. At some point, those two things are going to balance out, and what does that mean? It means there's no point investing further. So that's intuition, but the idea is that if there are diminishing returns in the world, then your ability to grow by increasing the capital stock would be limited. There's some point at which it's not worth it anymore. And what does that mean? Well, we do observe economic growth, which means it doesn't mean that we have a puzzle. It means that the deep driver of growth can't be added capital. The deep driver of growth must be this, improvements in technical progress. Okay, so that's very broad-brushed intuition. I'm going to show you this in a slightly different way again. Remember that I said last class that we actually have a production function that works reasonably well, which is this one. Real GDP seems to roughly equal some indicator of technology times capital to the third times labor to the 2/3. Remember this? So let's just make things easy and say that labor is the population. We know it's not, it's some share of the population, but again, it'll make it easier to do this. Remember, of course, we're not interested in GDP overall. We're interested in, I guess we could say, in order to have economic growth, why don't we say it's GDP per worker that has to be growing? Right, we know, okay, or GDP per person. So we want to divide this by the number of people. We want this to grow, right? This has to be true. Notice that by the rules of exponents, instead of writing L here, I can write L to the third times L to the 2/3, right? Because 1/3 plus 2/3 is 1, and L to the 1 is L. And why am I doing that? I'm doing that because, of course, if I can open this pen, these cancel. Notice I have k to the third over L to the third. I can just rewrite this. Oops. As follows. This is now telling me that in order to get growth per person, one of two things has to happen. Either I need better technology, or I need not just more capital, but more capital per person. Right? I guess that's intuitive, but here we have it. And capital per person here is raised to some power. And this power is less than 1. So, what is this picture going to look like if t is just some number? It's going to look like this. And actually, well, it's not going to go down, it's going to keep going up, but it's going to be flattening out. What is this flattening out? This is your diminishing marginal returns, right? If I go from 0 to 1, I get a certain gain. This is also kind of a refresher on what diminishing marginal returns are. I get this gain, right? If I go from 1 to 2, I do get a gain, but it's smaller. If I go from 2 to 3, the marginal gain continues getting smaller all the way out. So, aside from the intuition of how diminishing marginal returns might affect our ability to grow by accumulating capital, the production function that seems consistent with the data displays diminishing marginal returns. So it tells us, it looks like it's there. Any questions, thoughts, comments? So the conclusion is, if diminishing marginal returns are a thing, it must be that economic growth is ultimately driven by technical progress. So, let me now give you a little sketch, or I guess a flow chart, for how it is that growth works according to Neoclassical Growth Theory. For this, I might need a chair. So, let's start. For there to be growth, according to Neoclassical Growth Theory, there has to be an innovation, right? Some sort of improvement in technology. So step 1, technology increases. Right? We just have to assume that because otherwise there wouldn't be any growth. And notice, if you think about it, maybe that's a flaw in Neoclassical Growth Theory. It's telling us that ultimately technical progress has to do, is the root of economic growth. But did we ever explain where technical progress comes from? No, we just kind of assume it. Right? That's going to be one of the big problems with it. It's focusing entirely on the dynamics of capital and how it can't be the deep root of economic growth, but it doesn't explain the deep root of economic growth. That's going to be where new growth theory comes in. So first we need technical progress. We don't know where it came from. Second, what does that do? Notice that, I guess, we can actually represent that in this picture. Well, the first thing that does, before we go on, is that raises real GDP, right? If T goes up, this goes up. How do we represent this here? We can represent this in, well, we just increased real GDP per person for any value of capital, right? So it's the same thing as saying we just push this line up. What does that mean? It means the marginal return of having 1 unit of capital went up. The marginal return of adding a second one also went up, right? The marginal return of the third also went up. We've just made capital more productive. We just increased the marginal return to capital. On the other hand, remember, there's no point investing in capital past some point because it's costly, because those resources could be used to get more, to make food instead. But now we just raised the returns. We didn't do anything to the costs. So what would be a good idea to do now that we just suddenly made capital more productive? You should invest. You should make more capital. Some of this real GDP is investment. Actually, for 2 reasons. One, because in general, when you give people more income, they're going to invest some of it, right? You don't consume every dollar that you have. And if I just gave you $1,000, you'd probably save some of it. But aside from that, I just made capital more productive. So even more reason to invest. New investment means more capital. And so that means, since capital is rising, that means there's a second reason why real GDP should go up. So neoclassical growth isn't just telling us deep down the root of economic growth is technical progress. It is telling us that capital still has a role to play, not because it's the root of economic growth, but because when there is an improvement in technology, it gives you an incentive to invest more. What will happen next? What happens next, now you have more real GDP. So, same intuition, some of this new GDP is going to be investments. But this increase in GDP is different from this one, right? This one was driven by some new innovation that makes the capital more productive, which makes you invest in capital more. But then what happens? What happens once you start investing more in capital? Diminishing returns. So the increase in technology, the improvement in technology sets off, well, first, it itself causes growth, and that leads to reason to invest more. And when you invest more, that also increases GDP, but and which leads again to more investment, but each time it's a little less, a little less, a little less, because of the diminishing marginal returns. And so eventually, growth should stop. Or to be more precise, it should stop until and unless there's a new improvement in technology. So this is how economic growth happens in neoclassical growth, where we're putting heavy emphasis on the idea of diminishing marginal returns. First, growth has to be driven by improvements in technology. When improvement in technology occurs, it sets off this sort of virtuous cycle of investment, but of course, as the cycle progresses, it's sort of eroding its own value, right? Each time you invest, it lowers the diminishing marginal returns until eventually it's not worth investing any further, and that cycle stops, waiting for another innovation. And you might say, well, we don't see, well, this would maybe sound like we should expect to see waves of growth, and I guess some economists think that there are, and others would say not really, but there are different fields of activity. There could be, if we think that technical progress is sort of development and implementation of new knowledge, you might say, well, there are lots of different industries in reality, and some of them may be in this stage, and some of them may be in this stage, and since GDP is averaging over all of them, we don't see. That's probably a realistic picture of reality. Anyway, so this is a theory. Reality is reality, and the usefulness of the theory is going to be seen in how well it explains what we observe. So why don't we, now that we have a picture of how neoclassical growth theory works, why don't we confront it with the data? So let's use this theory to try and come up with some predictions of what we would expect to see, to the extent that this theory is useful. One thing that it predicts, again, is that growth should stop unless there's technical progress. You've seen some data on economic growth. We looked back over in some, I think we looked at one figure where there's like 100 years of data. Is growth stopping? No. Does that mean this theory is false? No, it just means that to the extent that this theory is useful, it must be that there's continual technical progress. So that's one prediction. Here's another more useful, perhaps, prediction. Suppose you had two countries. This is real GDP per capita. We're going to have two countries, and we're going to have, so we're assuming there's some way of making sure that we're measuring GDP consistently in two countries using the same units. And suppose this is country one. Let's call it A, I guess. Now suppose there's some other country, let's call it B, and for some reason country B is the same as country A in all ways except one. And the one way in which we're going to say country B differs from country A is that it has less capital. And you might say, how could country A and country B be the same in all ways and have less capital? There are several possibilities. What if country B is Puerto Rico? Why? Well, Puerto Rico recently had, a few years ago, experienced a natural disaster, hurricane. So what if country B is Puerto Rico having experienced a natural disaster, and country A is Puerto Rico if nothing had happened? So they're identical in all ways, except this one has less capital. Or what if country B is, I don't know, Japan in 1945, where a huge amount of the capital stock was destroyed by aerial bombing, and country A is Japan if nothing had happened. So, for some reason, country B is broadly the same as country A, and of course by the same as country A, what do I really mean? I mean they have the same technology, right? That's what being the same means in this context, except for the fact that you have less capital. What's going to happen to country B? I'm going to draw three possible paths. One is country B converges to country A. Another is it doesn't. Let's call this 1. Let's call this 2. And the other is that it falls away. According to neoclassical growth theory, which one would we expect to see? Would we expect to see B converging to A, getting closer? Would we expect to see B not converging? Or would we expect it to fall away? And remember, the key is the technology is the same in both. It's the only difference, the only reason B is down here is because it starts with less capital stock. Yes, sir?
You'd expect C.
I'm sorry?
So you'd expect it to convert.
You think it's, would it be 1? What does everyone else think? How many of you think 1? How many of you think 2? How many of you think 3? All right. And again, this is only according to this theory, not based on other information. So what happens to country B at this moment? It has the same technology as A, but less capital. What does that mean? I erased it, but you remember I had this picture of diminishing marginal returns. What's the return to capital in B? Is it higher than in A or smaller than in A? It's higher, right? Capital is scarce here. Whether because for whatever reason they started with less, or because, as again, it's Puerto Rico, some of it was destroyed. So whatever's left is particularly productive. So what should you do if you're in a place where the capital is particularly productive? You should invest. You're here. In other words, there's an incentive to sacrifice some consumption now to use those resources to invest more because the new capital goods are particularly productive. So if you're investing more, you're growing slightly faster. Yes?
But isn't there less capital for labor?
Yeah, exactly. That's precisely why the marginal return to adding another unit of capital is especially high. So you should. And so you grow faster. Now what's happening here? Well, now the marginal return's gone down a bit because you just added capital, but it's still higher than there because you still have less. And so you keep adding capital. Of course, each time you do that, the incentive to continue adding capital goes down. And of course, that's why you slow down and eventually converge to A. Where A could be, again, another country with similar technology, or A could be what would have happened otherwise if we think of B as being Puerto Rico after a hurricane or Japan after a war, where they would have been anyway. So that's a pretty strong prediction. Actually, that's two predictions. One, to the extent that countries have similar technology, we should see them converge. Two, after natural or man-made disasters, countries should bounce back. So we can actually check both of those, right? So let's do that. Okay. You've seen this figure before, right? And these are a bunch of countries in Asia and the United States, where the United States here is supposed to play the role of a large, fairly wealthy country, not necessarily the one with the highest GDP, but It's pretty high. GDP per capita, that is. Do you see convergence here? Yeah. So this is consistent with neoclassical growth theory, and what it would suggest about this set of countries is that, broadly speaking, they must share similar technology. Okay. In the case of the People's Republic of China, which is the dark green line at the bottom, it hasn't converged yet, but it's clearly in the process of converging. Let me find another one. How about this? So there's a project at a university in the Netherlands that tries to compute GDP going back like 1,000 years, which is GDP per capita, sorry, which is difficult to say the least, but well, I'm glad they're trying. And so that's how we have GDP for this place going all the way back there. If I drew a line through this thing, I mean, you can see that there's some almost literally bytes taken out of this series. Here is World War II. What happens? Does it follow path 1 where it converges? Does it follow path 2 where it just sort of stays behind? Does it follow path 3 where it falls away? It follows path 1, right? It goes back where it kind of would have been anyway. And same here. This would be, I guess, this is World War I, this is Great Depression. It always bounces back. And as you can see, Germany didn't have a great 20th century, but in the end, it all kind of washes out. So that's a look at the second prediction of the when capital is destroyed, when there's some kind of disaster, do you eventually get back where you kind of would have been anyway. So both of these are actually consistent with neoclassical growth theory, suggesting maybe it has something to teach us. But what about this? You've seen this figure before, right? Where we are not looking at selected countries, we're looking at a broader set. And so this is telling us one of the two, I guess, major limitations of neoclassical growth theory. It's not explaining this. These countries aren't converging. Well, it's sort of explaining, but in a way that's not terribly useful. Remember, what neoclassical growth theory is telling us is if countries share the same technology, I guess what that means is if countries share the same technology in the sense of whatever it is that the efficiency of turning inputs into outputs, then they should converge. Right? That's what it says. What does that mean? It means if they don't converge, they must not share the same technology. That's the contrapositive of that statement. It means that logically those two statements have the exact same value. So this is not telling us that neoclassical growth theory is not useful, but what it's telling us is these groups of countries must differ in some way that dramatically affects how efficiently they convert inputs into outputs. Someone had their hand up. Yes. Yeah.
It looks like some of them converge, though, green and yellow.
Yeah, the green and something interesting is happening in the yellow. Well, yellow is East Asia and Pacific. So that's exactly the same set of countries from this figure. Yeah.
Couldn't Europe also find this sort of split, like a binomial split, Western Europe and Eastern Europe? There might be trends where convergence one way or the other. They're just sort of hidden because it's combined into one.
Yeah, indeed there are. Yes, so here we're averaging across large groups of countries, and so, for example, if you look at, let's see, where's Latin America and the Caribbean, which is the green line, which isn't obviously converging, that has several cases all mashed in together. So you have Peru, which has had explosive growth since the early 90s, and then that's mixed in with, I don't know, Argentina that keeps sort of running into trouble every few years, defaulting and then defaulting again and again and again. And they're all averaged out. So you're absolutely right, of course. I would have liked to, obviously how many countries are there in the World Bank database? I think there's something like 240 countries or so that they're tracking separately. And obviously I can't put all of them separately on the board. But you're welcome to look at all those data. They're freely available on the World Bank website. And yeah, there are some growth miracles. There's some growth disasters, and they're all, and within groups they're kind of averaged out. But it is interesting, as you say, East Asia and Pacific kind of stands out here. This is the only one that actually does seem to be sort of converging. But the broad point is that these dynamics that are ultimately driven by decreasing returns to scale, we do see them in some cases. We see them after disasters, and we see them for the case of these folks. But broadly, we don't see them, which tells us there must be something fundamentally limiting the technology, either the spread of technology, or it must be some other aspect of technology that doesn't spread. These institutions, perhaps. Okay. Any questions, thoughts about this, or any of the others? I'm going to hint at something that we'll discuss later. Remember when we were talking about convergence, we were saying line A might be Puerto Rico if there had been no hurricane, and line B is, well, after a natural disaster or man-made disaster. Some of these places, let's say, I don't know. Let's pick Korea. Just as an example. These data only go back to 1980, unfortunately. It would be nice if we had a slightly longer series. But Korea and the United States aren't necessarily, like, we can't think of them as Korea being the United States, except that something happened and pulled them back. Well, actually, maybe we could if we go back far enough in history. But if we go back to early in the 20th century, Korea was one of the poorest countries in the world. By Korea, they mean South Korea, but back then there was no distinction. So one thought to entertain is that you can have countries, actually, maybe let's go back here. Maybe let's forget Korea and let's think about this picture. Maybe this is better. Well, Korea is in East Asia and Pacific, so let's go there. So these lines aren't converging mostly because there must be some sort of deep difference in the technology. And we suggested that that deep difference could be something to do with scientific knowledge, but it might not be, right? It could be something to do with institutions. And institutions, things like the legal system, regulations, and so on, they don't change very often, right? They kind of, well, they may be baked into the constitution of whatever country you have in mind, bless you. But sometimes they do. Right? There could be a revolution or some sort of reform. And if there's a revolution or reform that deeply changes your technology, what might you expect? Well, if it's an improvement, you may go from being one of these lines that isn't converging to suddenly converging. Or if it's the opposite, if it's a reform or revolution or whatever that actually makes everything worse in terms of efficiency, then you do the opposite of converge. You don't see that in any of these broad examples, but again, keep those possibilities in mind for when we revisit this figure later on. Let's see, how are we doing for time? Any questions, comments, thoughts? So, to back up, we looked at, we're trying to theorize about economic growth. We started by thinking, well, we've discussed the production function. We want to combine the idea of the production function with this early concept from micro of diminishing marginal returns. That tells us intuitively that you can get growth in the long run by accumulating more and more resources. We spelled out how that implies economic growth must occur. There must be, first, some improvement in technology to stimulate the start of the growth process. That doesn't mean that capital doesn't play a role, because it sort of plays a role in implementing the technical progress, right? In fact, literally, if you think about the fact that new technologies often mean new machines and new devices, or, again, new procedures that we need to learn, it may literally require new capital in order to be implemented. But as the new capital accumulates, the marginal returns go down. What does that imply? It implies convergence among technologically similar countries. It implies recovery after natural disasters. We saw all of that in the data, suggesting that there's something to this. On the other hand, we also saw other things that tells us that there must be more to the story, because a lot of countries don't converge, which in the language of this theory means the technology must be different. And we're also lacking entirely an explanation for why technology improves in the first place. In this theory, it's almost as if it happens randomly, right? There's no explanation for it at all. But, well, does technical progress happen by accident? No. Why does technical progress occur? Yeah. Sorry? I guess, I think what you mean, tell me if I'm wrong, is that coming up with a new thing, or a better thing for that matter, is itself a form of investment. Right. So in order to invent, I don't know, the iPhone, someone, or more likely a team of people, had to sit down and think carefully about how to make it. And of course, backing up, they must have thought there must be some reason, there must be some demand for this thing. Like, if we make this thing, people will buy it. And if people buy it, what's going to happen to us? We'll get rich. So, right, what's missing here, I guess, maybe is the idea that investment here is a very limited concept. It's just investment in physical capital. And I forget if it was in this class or in the other class, because I have two sections of this class. When we defined GDP, someone said, is research and development considered an investment when you're measuring GDP? Was that this class? No. Okay. It's a great point. And it used not to be, but now it is. Because they realized, generating new knowledge or investing in research and development is creating new knowledge, which is an asset, a productive asset. That lives for a while, just like physical capital. So, yeah, maybe what's missing here isn't that, there's another form of investment. When the diminishing marginal returns to exploiting the pre-existing technologies is running down, what do? Do you give up? You come up with something new. Or you try, at least. And so far, we haven't run out of ideas. Is there a limited stock of economically useful knowledge? We don't know. So far, so good. one thing that these folks, I guess, neoclassical growth theorists, did realize, I mean, they realized that their concept of knowledge, they realized that their concept of capital was maybe limited, but not in the way that we just discussed. What they thought was, although I guess it's a step in that direction, one thing that some of them observed was, there's physical capital here, machinery and structures that we can invest in that has diminishing returns. But there is another form of capital. They weren't thinking about R&D, but they're thinking that there's another form of capital that kind of accumulates, and that is knowledge. Like you and I, actually let's talk about you. You're here, you're college students, and what are you doing here? Are you here to party? No, you're here to learn. And the more you learn, the more it builds up your knowledge, your productivity. It enables you to do more things that you couldn't do before. It enables you to perform, it increases your skill at doing certain things. Of course, you all have different majors, right? The chemical engineers are increasing their skill at combining things and operating certain kinds of machinery. The business majors are improving your ability to manage teams and so on and so on. The economics majors are improving your ability to teach econ to people or hopefully provide knowledge that they can use in their daily lives or also as business people or in government, improving their ability to develop good policies and so on. We don't all have necessarily the same knowledge, but the point is that by being here in the university, we're pushing that frontier and learning more and more and making ourselves more productive and increasing our, what they call human capital. Okay? So, one thing that was observed here is that as well as physical capital, you might be able to think of what you and I embody and add to the economy the more and more and more we learn as a form of capital itself that we'll call human capital. And of course, what is college for? It's to add to your human capital. And you may have some fun as well, but ultimately it would not be worth being here, spending, $250,000 plus living expenses if it weren't adding to your human capital. And the fact that you're here means it probably is, and you know it. Any questions, thoughts, comments? Interestingly, we have a graduate student in the department whose research indicates that the amount of human capital you learn in college actually depends quite a bit on your major. Just throw that out there as something to think about when you're deciding what you want to major in. I used to have on my door, actually it's somewhere out there, I think GW has some sort of data on your income by major when you leave. It's not the only reason to pick a major, but it's good to have those data. You need to make informed decisions. Economists do really well, by the way. Because we can work in finance, we can work in government, we can teach. We have a lot of options. We can become lawyers. Econ majors do disproportionately well on the LSAT. That's my pitch. Okay, let's see. How are we doing for time? Have about 20 minutes. So, let's see. What can I say? I guess when economists try and measure human capital, very often what they go by is the number of years of schooling. But if you think about it, that can't be quite right. Right? As discussed, it varies by major, if you're thinking of people who are in college. And also, a year of schooling here and a year of schooling somewhere else might not be the same. So it's a very crude, let's say, measure of it. But so one of the things that research economists like me struggle with is to try and, we understand that this is obviously important, how do you measure it? It's pretty tough. And I guess, well, I actually have a research paper on this where we try to measure human capital by essentially measuring the returns to schooling and the returns to experience in different countries using World Bank data. And then we did a simulation to try and figure out, well, schools shut down for 6 months in various places and 10% of the workforce was kicked out thanks to COVID. How much did that erode human capital? To the extent that you learn from being in school and you learn from experience. And the losses are quite big. It's like 1% of GDP per year for the next 20 years. Because, you know, unless, of course, somehow magically we relearn whatever we didn't learn through, and of course you can't, lost experience is just lost, right? You didn't work for you. So whatever you didn't learn in that year, you just didn't learn it. So again, human capital is probably, so I guess to sum up, a last lesson from neoclassical growth is the idea that human capital might be very, very important. Again, labor is 2/3 of GDP, so that's the sort of extent to which it could be important. All right. Any questions, thoughts, comments about any of these elements? Diminishing marginal returns, the consequences, the idea of human capital? If not, then I guess I prepared yet another of these exit quizzes for you that, as discussed, I've made them shorter so that they don't take too much time. And someone asked me if I could make them available outside of class. I'm going to do that shortly. Okay. So please take out your favorite device and log in. What's going on with the music? Well, if there's no sound, there's no sound. I guess it's not the end of the world. It says error. I hope I opened the right one. I see we have some guests here like Cristiano Ronaldo. And as usual, if you are the winner, I have a little something for you up front. Okay, let's wait a little longer for people to log in. Don't want to wait too long. All right. Let's get cracking. Ready, steady. All right. Are we good? I think that's good. Darwin Nunez is here as well. Interesting. I didn't know there's so many soccer players in the class. All right. I did pick the right one. So, in neoclassical growth, the ultimate driver of growth is what? Physical capital, human capital, technology, or energy? It's technology. Without it, nothing will happen. Next. The key concept in neoclassical growth is what? decreasing marginal returns, increasing marginal returns, no population growth, or constant capital per person. The thing I just erased from the board. Next. JP is on top. Type the answer. Knowledge in your head can be thought of as something capital. Time's up. Of course it is human capital. Next, Neoclassical Growth Theory explains the source of technical progress. Yes or no? True or false? It is false. It doesn't. Harrison's back on top. The data suggests that all countries share the same technology, broadly speaking. It is false again. So let's see. Third is JB. Good job. Second is Jeffrey. And top is Harrison. All right, Harrison, I have a little something for you. Everyone else, thanks for coming. Hope that was useful. I'll try and post this a bit later. And well, see you on Wednesday or in office hours. You know where to find me.